Today we're looking at some harder questions that involve congruence. So just a reminder, the symbol for congruence is the 3 horizontal lines. The symbol for parallel is 2 vertical lines. The symbol for perpendicular, which means 90 degrees, is the upside down T. And to bisect something means that you're going to cut it in half. So in today's lesson, we're going to be using congruence to help us prove properties of our quadrilaterals. So our first question is, opposite sides in a parallelogram are parallel, prove that it has opposite angles that are equal. So I can only use the properties that I've been given. I'm going to draw a parallelogram to get started. So here it is. And I'm going to give myself some labels. So I'm going to go A, B, C, D. It says opposite sides in the parallelogram are parallel. Okay, so that's a property that I can use. That side's parallel to that side, that one's parallel to that one. Okay, we do know that the opposite sides would be equal, and we know things about the angle as well, but we're trying to prove that property. So I need to use congruence to prove that the opposite angles are equal. To do that, I'm going to have to make some triangles. So I'm going to construct a line that goes from D to B. And then I'm going to have a look in triangle ABD and triangle CDB. So ADB is this triangle I'm drawing here in orange, and CDB, let's make that one green, CDB. Okay, so they're the 2 triangles, and I want to prove that they're congruent. So I don't have many sides. The only side that I have is DB here because it's a shared or a common side. Everything else is going to have to be angles. So I'm going to have to use AAS. So the parallel lines are going to help me get equal angles. I can use alternate angles. For example, angle DBA, so DBA would be this one in here, is going to be equal to BDC, which is this one here. Okay, so I'm going to write that down. Remember to match your vertices. So angle DBA equals angle BDC. Now the reason that I know they're equal, is because they are alternate angles on parallel lines. So I'm going to go alternate angles. Now normally we would say are equal, but because there's 2 different sets of parallel lines here, I'm going to say which parallel lines I'm using. The parallel lines would be DC and AB. So on DC parallel to AB. Okay, let's do that again. I can do alternate angles going the other direction, and that angle I'm putting a dot in, and that angle, they would also be alternate. So let's write those ones down. Angle ADB, so that's the first one in the orange triangle, is equal to, match the vertices, CBD, because they are alternate angles on, now that's using the CB and DA parallel lines. So that's AD parallel to BC. Okay, and finally my side was BD is common. Okay, that means, therefore, triangle ABD is congruent to triangle CDB because of AAS. Now that I know that the green triangle and the orange triangle are congruent, that means that everything about those triangles is the same. So if something's in the same position in each triangle, they're going to be equal. So I want to prove, remember, that the opposite angles in that parallelogram are equal. So I can now say, hence, because of my congruent triangles, angle DAB, which is this one down here, DAB is going to be equal to angle BCD, which is this one up here, because they are corresponding angles in congruent triangles. Now we use that word corresponding, but that's not the corresponding that we use for parallel lines forming the F shape. The corresponding means they are the matching angles in those congruent triangles. So our reason is corresponding angles in congruent triangles. Okay, we also know that AD is going to be equal to CB, and AB is equal to CD because they would be corresponding sides in the congruent triangles. Okay, so that's probably a little bit more than I needed to know, but I have shown in this line here that the opposite angles of that parallelogram are equal. And I could also do a therefore to show the other ones. Angle ADC is going to be equal to angle CBA. Okay, I probably should write the word similarly there. Okay, to show that these opposite ones here would also be equal. Okay, so let's look at question B. Use the property that opposite sides of a parallelogram are equal to prove that a rectangle with all angles of 90 degrees has diagonals of equal lengths. Okay, so we know that we're trying to use a rectangle because it says to prove that a rectangle with all angles of 90 degrees. Okay, so rectangle with all angles 90 degrees, there it is. I'm going to give my vertices some labels, A, B, C, and D. It says use the property that opposite sides of a parallelogram are equal. So I can use that that side is equal to that side and that side is equal to that side. And I want to prove that the rectangle has diagonals of equal lengths. So if I were to draw my diagonal A to C, I want to prove that that has the same length as B to D. So what triangles am I going to prove here are congruent? Let's take triangle ABC, which will be this one here, because that would give me my diagonal AC. And if I also take my second triangle to be DCB, then I would have the other diagonal DB. So let's prove that they're congruent. So let's go in triangle ABC and triangle DCB. Okay, what do we have? We know that we have the side markings. So I have one line and two lines. So I've got two sides that I can use. And I also have the right angle. Now this is not a right angle hypotenuse though. Okay, I don't have the hypotenuse side yet. It would actually need to be SAS because the right angle is the included angle. So the first side I'm going to use in my orange triangle, I'm going to use the side AB. It's going to be equal to CD. And the reason I know that they're equal is because opposite sides of a parallelogram are equal. That's what I was told in the question. Parallelogram. Okay, then the angle is going to be the right angle. In the orange triangle, it is angle ABC. In the green triangle, that matches with angle DCB, and that's because we were told that we were given an angle of 90 degrees. I'm going to use BC is common, because it is shared with both of those triangles. Therefore, triangle ABC is congruent to triangle DCB because of SAS. Now that I know that those triangles are congruent in every way, I can now say, hence, AC, the first diagonal, is equal to DB, the second diagonal, because they are corresponding sides in congruent triangles. Remember that corresponding just means matching. Corresponding sides in congruent triangles. Okay, and I've therefore shown that the diagonals are equal. Okay, on the next page, question 2. Prove that if opposite sides of a parallelogram are equal, then it is a parallelogram. So the diagram is there for us, and it's got the markings on there to show that the opposite sides are equal. So I'm going to put some letters on here, A, B, C, and D. To prove that something is a parallelogram, I need to show that the opposite sides are parallel. To do that, I'm going to have to show that the angles, like that angle there and that angle there, if they're equal, then they're alternate angles, and that means the lines DC will be parallel to AB. And then I could do the same thing going that way, that one and that one. If they're equal, then I can show that alternate angles are equal and the lines must be parallel. So to know that those angles are equal, I'm going to have to do a congruence proof. So the triangles that I'm going to look at are triangles ABC. So ABC is that one, and triangle CDA. CDA, this triangle here. So I have the markings showing me one line, and 2 lines, 2 lines. So I can use 2 sides, and I also have the AC as a share side there, a common side. So I'm going to be able to use SSS. So the first side I'm going to start with in the orange triangle is AB. AB is going to be equal to CD in the green triangle, and that was given to us on the diagram. Then BC is going to be equal to DA. That was also given to us on the diagram. And the third side is AC is common, or is a common side. Therefore, triangle ABC is congruent to triangle CDA. Make sure the vertices match because of SSS. Now, what conclusions can I draw from there? Remember, I'm trying to show that it's a parallelogram. So I now know that angle DCA, which is this one, is going to be equal to BAC. So I'm going to write that down. Hence, angle DCA equals angle BAC. I also know that angle DAC is going to be equal to angle BCA. Okay, they're both for the same reason. It's because corresponding angles in the congruent triangles. We just proved that those triangles are congruent, so we now know that those angles match. So, and angle DAC equals angle BCA, and we write our reason down: corresponding angles in congruent triangles. Now, if we know that those angles are equal, then using those little arc symbols, because they're alternate, that's going to mean that AD is going to be parallel to CB, and DC is parallel to BA. And both of them have the same reason. It's because the alternate angles are equal. If the alternate angles are equal, it means that the lines must be parallel. And I can say, therefore, ABCD, which is the name of that quadrilateral up there, is a parallelogram. Because I've shown that the opposite sides are parallel. Okay, one last question. Prove that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. Okay, so I'm going to draw a quadrilateral here. Now we're expecting it to be a rhombus, so I'm going to draw one that looks a bit more like a rhombus. Actually, let's make that a little bit shorter. Okay, so prove that if the diagonals bisect each other, so if the diagonals like this, bisect means that it cuts those side lengths in half. So that side would be equal to that side, and that one would be equal to that one. If they bisect each other at right angles, so I also know that these little angles in here are all right angles. And I want to prove that it is a rhombus. So to prove that something is a rhombus, it needs to have opposite sides parallel, and it needs to have all sides equal. So I need to prove both of those properties. So I'm going to give my shape up here some labels: A, B, C, D. I need one for the middle, which I'm going to call E. Now the triangles that I'm going to prove, if I take triangle DEC, so this one here, and I'm not going to do the one across from it, I'm going to do BEC, the one next to it. Because if I can prove the one next to it is the same, then all four of them will have to be the same, won't they? So let's write that down. In triangle DEC and triangle BEC, I have got some sides in there that I can use, and the right angle's in between the sides, so it's going to have to be SAS. So let's write down what we have the same. In the orange triangle, I have a one line marking on DE, so that's going to be equal to BE. Okay, that was given because we were told that the diagonals bisected each other, okay? So we were told that in the question. We also know our angle, which is the right angle. Angle DEC equals angle BEC. We were told that as well, that they were 90 degrees. And for my orange and green triangle, I have got a common side there, side CE. So I now know, therefore, triangle DEC is congruent to triangle BEC because of SAS. Now, I'm not going to do the proof over and over again for all four triangles. I'm just going to say, similarly, triangle DEC is going to be congruent to triangle BEC. They're the ones that I just proved. but that's also going to be congruent to BEA and also congruent to triangle DEA, because all four of those triangles have the same angles, the same right angle and the same side markings for SAS. So that means, therefore, that all those outside side lengths of that rhombus are going to be equal. So DC equals CB, which equals BA, which equals DA. And that's because they were corresponding sides in congruent triangles. Okay, so I've shown that all the sides are the same. That's the first thing I had to show. But I also want to show that the opposite sides were parallel. So, and let's keep going. The angles CDE and angle ABE and angle ADE and angle CBE, they are also going to be equal because they are corresponding angles in congruent triangles. Okay, so that means that I've now shown that I've got some alternate angles are equal. So that means, therefore, AB is parallel to CD and AD is parallel to CB because the alternate angles are equal, which means they must be parallel. Hence, I'm just going to write a little conclusion here. Hence, ABCD is a rhombus since all sides are equal and opposite sides are parallel. Okay, and that's it for 6C.